vector analysis. Vector analysis. So we shall be looking at divergence. Now, divergence is shortened as div. Div F, for example, div of a force field, the divergence of a force field. Divergence, div, means nabla or del dots. Divergence is equal to gradient dots, dot products. So div is gradient dot. By implication, if you are expected to look at div F, divergence of F, this gives us I direction partial respect S plus J direction partial respect Y plus K direction partial respect Z is a dot product function of F. F along the x-axis, I direction, F along the y-axis, J direction, F along the z-axis, K direction, plus. Now, F can imply a force field, a kinematic field, a dynamic field. But the most important thing, it is a dot product. Take note that I cap dot I cap equal to J cap dot K cap, dot J cap is equal to K cap dot K cap, and this is equivalent to 1 in vector analysis because it is dot product. So when we work with this concept, we now get that divergence of F, perhaps a force field, it could be electromagnetic force field, it could be a mechanical force field, a tripartite directional field function with respect to X, with respect to Y, and with respect to Z. That's a tripartite directional vector function. So that divergence F will now be given partial F x-axis respect x plus partial F y-axis respect y plus partial F z-axis respect z. Take note that divergence function is, of course, a scalar field function. It is a scalar field function. Now, a scalar field function because there is no other attached directional field. The I, the J, the K has left it after the multiplication, the dot product multiplication. So the unit is single unit with respect to the function and has no directional unit. Hence, it is said to be a scalar field. Take note, gradient operator, grad F or grad phi is usually having a vectorial connotation. At the end of the answer, it has vector. But the divergence has no vector. So that is why divergence functions are usually scalar field functions. For example, if F is equal to 2x squared I direction plus y squared, let's say y j direction plus z cubed k direction. If this is a force field function and you are expected to find nabla dot vector operator dot f of the function, vector operator f of the function, this gives us solution to this. Nabla of vector operator f is equal to I direction partial respect S, J direction partial respect Y, plus K direction partial respect Z. This is for nabla, the del operator, Now, this is a dot product of the function given. Function given is 2x squared I direction plus yj cap direction plus zq k cap direction. Mind you, this is a dot product function. So at the end of this evaluation, take note that I dot I is 1, J dot J is 1, K dot K is 1. So that is to say, we'll be having a partial function, partial derivative of 2x squared respect partial x, plus partial derivative of y respect partial y, plus partial derivative of z cubed respect partial z. That is the implication of the connotation by expansion with a dot product multiplicative analysis. So with this obvious connotation, when we partialize subsequently, we differentiate 2x squared, we are getting 4x, because 2 will come down based on differentiation, plus 1. If you differentiate y with respect to y, it is 1, plus 3z squared. This is the final answer. This is the final answer. Take note of divergence theorem. Take note of divergence theorem. It's such a very magnificent factor in vector analysis.